Let's talk about law of sines and law of cosines today. So we talked about the trigonometric ratios already, and you notice that the trigonometric ratios sine, cosine, tan and the reciprocal of those works only for right triangles. What if you get a acute triangle or obtuse triangle and wanted to figure out the um, sides or unknown sides or unknown angles? So how do we use the trigonometric ratios to solve normal triangles, not the right triangles, the acute triangle or obtuse triangles? So let's see how this works. So today's lesson is on law of sines and law of cosines, and we'll go over this and we will do some practice problems. So let's take a normal acute triangle ABC, and in order to find the area of that triangle, you need an altitude, that is the perpendicular from the opposite vertex. So we drew an altitude from C to AB. So you can use the altitude of a triangle to find the relationship between the triangle side length. So now you can see you have two right triangles, the small right triangle, and there is one over here that's also a right triangle. So we can use the normal like trigonometric ratios to solve the sides for these right triangles. So we are going to take some trigonometric ratios here. So you can see in triangle ABC, let h represents the length of the altitude from C to AB. From the diagram, sine A is equal to sine A. Sine of this angle is equal to opposite side over hypotenuse. So we are looking at the small right triangle. So sine A is equal to opposite over hypotenuse, which is sine A is equal to h over b. And sine B from the other triangle. B is the angle opposite side over hypotenuse, which is sine B is equal to h over lowercase a. That is the side opposite to angle A. I don't know if you have noticed. We took the side opposite to angle A as lowercase a, and the side opposite to angle B is lowercase b, and side opposite to angle C is lowercase c. So you need to notice that because that is the pattern we are going to follow. So by solving for h, you find that h is equal to b times sine A. So from sine A is equal to h over b and sine B is equal to h over a, you can see h is equal to b times sine A, and from the second equation you can see h equal to a times sine B. So now by using the transitive property of equality or substitution, you can see b times sine A is equal to a times sine B. Now if you rearrange, you can see sine A over A. So if you take an angle, you take the side opposite to that angle. So sine A over lowercase a, that is the side length, is equal to sine B over lowercase b, that is the side opposite to angle B. You can use another altitude to show that these ratios are equal to sine C over C. Now we are going to the first theorem in this lesson, and the theorem is called the law of sines. So What is the law of sines? For any triangle ABC with side length A, comma B, comma C, sin A over A is equal to sin B over B is equal to sin C over C. And remember, lowercase a is the side length opposite to angle A, and lowercase b is the side length of the side opposite to angle B, and lowercase c is the length of the side opposite to angle C. So sin A over A is equal to sin B over B is equal to sin C over C. This is called the law of sines. And when do we use this? You can use the law of sines to solve triangle if you are given two angle measures and any side length. Doesn't matter if it is an included side. Look at the way they write, like S is in the middle of A and A. That means S is an included side, or S can be an excluded side as well. So you can write AAS. Or two side length and a non-included angle measure. So you cannot have an excluded you cannot have an included angle measure. You need to have an excluded or non-included angle measure. So SSA, two sides and an angle. If you know the three knowns, like if you know three measurements of a triangle, you can find the other three of any triangle using the law of sines and law of cosines. So I hope you understand law of sines and law of cosines. Now we are going to see what if they give you two sides and an included angle. What can we do to figure out the unknown values of a triangle, unknown measures of a triangle? Law of sines cannot be used to solve every triangle. If you know two side length and the included angle measure, or if you know all three side length, you cannot use the law of sines. Instead, you can apply the law of cosines. So we are trying to figure out what is law of cosines. So let's take an acute triangle, the normal acute triangle, and mark all the three sides, and we mark the same way, like lowercase a is opposite to the angle A. The side opposite to angle B is lowercase b, and the side opposite to angle C is lowercase c. And we drew an altitude from C to AB, opposite vertex to the base, and we mark that as H. And the two segments of side C we marked as X and Y. Now our goal is to find A, and we already know what is the length of AC, that is B, and the length of AB, that is C, and the measurement of angle A. So we are trying to connect A with B, C, and angle A. So we are trying to use Pythagorean theorem to connect these three unknowns. So let's take triangle number 1, which is on the left side, the smaller one, and we can clearly see the common side to both those right triangles is X. So I'm trying to find H. So H squared is B squared minus x squared using the Pythagorean theorem from triangle number 1, right triangle number 1. And we are going to do the second right triangle, and we are trying to calculate h. So h squared is a squared minus y squared using the Pythagorean theorem. Now we got the same quantity h squared, so we are trying to connect a, b and c. So let's see, a squared minus y squared. Okay, we got only part of c, so we need to connect that with c. Actually, we don't know x and y, so let's try to use the transitive property of equality or substitution and write b squared minus x squared equal to a squared minus y squared. And our goal is to find a, so let's make a squared alone on the left side, so we can add quantity y to the second power to both sides. So I get a squared equal to b squared minus x squared plus y squared. I added plus y squared or positive y squared to both sides of the equation, and I got 0 pair here, so that plus y squared stays on the right side. I switched the sides here. So a squared equal to b squared minus x squared plus y squared. Now we know b, so but we have to somehow connect x and y to c. So let's replace y equal to c minus x. From the triangle you can see y is equal to c minus x. So let's do that equation as a squared equal to b squared minus x squared plus, instead of y we are going to substitute c minus x to the second power. Now you can see it is just like multiplying c minus x times c minus x. Use area model. So it is b squared minus x squared plus, when you expand c minus x to the second power, or when you multiply c minus x by c minus x, you will get c squared plus x squared minus 2cx. Now you can see we have a 0 pair. Negative x squared and positive x squared will make a 0. So you have now a squared equal to b squared plus c squared minus 2cx. Now let's look at our equation. Yes, we need to find a. So we have a to the second power. So we can easily find a. We know b. So b squared we can easily find. C we know c squared. And c we know. But somehow we have to connect the unknown x with the knowns. So again, let's go back to the right triangle 1. So you can see x is equal to, how do I connect x? I cannot find x just like that. I need to use trigonometric ratios. So let's use trigonometric ratios. So for that, so I'm going to use trigonometric ratios. So I need x, I know a, I know b. So how do I connect x, b and angle A? So if I look at angle A, x is the adjacent side and B is the hypotenuse. If what is the trigonometric ratio that relates the adjacent side to the hypotenuse? That is cosine. So cosine of A is equal to adjacent side, that is x, over the hypotenuse B. Now let's see. I know cosine A. I can find cosine A because I know angle A and I know B. So x will be equal to B times cosine A. So we connected the unknown x with the known quantities B and angle A. Now let's substitute this to the equation. So I get A squared is equal to B squared plus C squared, B squared plus C squared minus 2C times B cosine A. So let's rearrange 2BC cosine A. That will be the law of cosine. So let's look at this closely. The unknown side A squared is equal to the sum of the squares of the other two sides minus 2 times the product of the known sides times, or we can say the product of 2 and the known sides and the cosine of the included angle. So that A will match with the unknown A and the other two. So A squared equal to B squared plus C squared minus 2BC times cosine A. There is a pattern here. If you understand the pattern, you can easily figure out the other formulas. So now you can easily figure out the other two side length by using this pattern. So if I want B squared, I will go, oh, what are the other two sides, which is A squared plus C squared minus 2AC, and the angle we are taking cosine of that angle, cosine of the angle opposite to the unknown side, which is cosine of B. So B squared equal to A squared plus C squared minus 2AC cosine B. And if you want C squared will be the other two sides, which is A squared plus B squared minus 2AB cosine of the angle opposite to C, which is uppercase C, cosine C. So these are the three laws that you are going to use when you know three sides and you want to know one angle, or if you know two sides and the included angle. So let's do some problems using law of cosines and law of sines. So the very first thing you need to do is you need to know what law you need to use to solve the triangle. So if you look at a triangle and you see a triangle that is not a right triangle, that means you may have to use law of sines or law of cosines. Now you need to identify which one to use. For that, first you need to look at the given measurements. So in this triangle ABC, number 6, the triangle ABC, they gave you two angles and one side. Two angles and one side. So that is only for the law of sines, because remember the law of cosines is for two sides and the included angle, or three side length SSS or SAS is for law of cosines. So you need to kind of remember the laws and see which one to use before you start solving the problem. So we can see we can use the law of sines here, because law of sines is sine A over A is equal to sine B over B is equal to sine C over C, but let's take two at a time. And sine A is sine 50 over A is the side opposite to 50, which is BC. We don't know what that is the unknown. And sine B is sine 30 over B is opposite to 30, which is 22. Which is 22. Now this is a proportion. You can do cross multiplication. So you go 22 times sine 50. Remember, when you enter the trigonometric ratios or trigonometric ratios on the calculator, you need to remember to write the number before, or you put parentheses around 50. So it will, otherwise it will calculate sine 50 times 22. So you will be getting a different answer. So remember to remember, before you plug it in the calculator, you need to know that is 22 times sine 50. It's always safe to put the parentheses around 50 when you plug it in the calculator, is equal to BC times sine 30. So we are trying to figure out BCS. So you divide by sine 30 on both sides. Divide by sine 30. So you plug it in this in the calculator, saying 22 times sine 50, 50 in parentheses, divided by sine 30. So that is BC. So you will be getting BC is approximately equal to 33.7 units. 30, I'm sorry. It's to 33.7 units. It's approximately equal to 33.7 units. Same way you can find AB. So please find AB, and the third angle is easy to figure out, because the third angle is like angle C will be 180 minus, because some of the angles of a triangle is 180. So it's 180 minus 50 plus 30, which is going to be 100 degree. Now calculate angle, and you need to calculate side AB also. So for the number 7, this is the same type of problem. They gave you two sides and an excluded angle. So you can use again sine A over sine B. Sine A over A is equal to sine B over B. So let's put the equation down. So it is sine 82 over 25 is equal to, we know only AC, so let's take that. That is sine B over 16. Using this, you can calculate sine B, because sine B is, when you cross multiply, you will get 16 times sine 82 is equal to 25 times sine B. Then you can calculate sin B is equal to 16 times sin 82 over 25. So B will be sine inverse of that quantity, which is 16 times sine 82 over 25. And remember to put parentheses around the angle, so the calculator will give you the correct measurement. I'll give you the answers for the answer for measurement of angle B is measurement of angle B is equal to what did I get? 39.3 degree. Then measurement of angle C will be 58.7 degree, and when you calculate C, you will be getting C equal to I don't think I'll have enough space here. So I'll write down C here, and we will do this problem on the next page. So C equal to 21.6. C equal to 21.6, and we will do number 8 on the next. Now let's do the problem number 8. We already did number 6 and number 7, and we are doing number 8 now. On number 8, they give you all the three sides. So we can use only law of cosines, and let's decide which side to use first, or which angle you want to figure out first. So let's say we need to figure out angle so we are trying to figure out angle C first. So we are doing C squared is equal to A squared plus B squared minus 2AB times cosine C. It doesn't matter which angle you use or which side you use, but one of the side is equal to the sum of the squares of the other two sides minus 2 times the length of the two sides times the included angle of those two sides, or the angle opposite to the unknown side. So let's substitute. So 3 squared is equal to 7 squared plus 5 squared minus 2 times 7 times 5 cosine C. So the unknown is the angle C. So let's do the exponent first. 9 is equal to 49 plus 25 minus 70 cosine C. So you can use the calculator, but be careful to put parentheses and everything to follow the GEMDAS. 49 plus 25 is 74 minus 70 cosine C. So it will be when you can see 70 cosine C is equal to 74 minus 9, and you can divide both sides by 70. So is equal to 65 over 70. So C is equal to cosine inverse of, in parentheses, 65 over 70. So you will get C approximately equal to 21.78. And same way you can do A cosine B, use cosine B like 7 squared using the equation. Let me pick another color so I can. Great, it's not working. Okay. So if I'm doing the other side, I will get 7 square is equal to 3 squared plus 5 squared minus 2 times 3 times 5 cosine b. You can see 49 minus 34 is equal to negative 30 times cosine b, and 49 over 49 minus 34 is negative, no, it's 15, it's positive 15 is equal to negative 30 cosine b. Once so it's cosine b is equal to negative 1/2. So b is equal to, oh, it's not working, I'm sorry. So b is equal to cosine inverse of negative 1/2. So if you plug it in that to the calculator, you will get angle B, measurement of angle B is equal to 120 degree. It's equal to 120 degree. Now since we know measurement of angle C is approximately equal to 21.778, and measurement of angle B is equal to 120 degree, you can easily calculate the third angle using the triangle sum theorem. So 180 minus these two quantities, which you will get measurement of angle C is 21.8. No, that's what we got here, 21.78, and measurement of angle A would be 38.2 degree, approximately equal to 38.2 degrees, if you take this as 21.8 degree. So if you add all these three, you will get 180 degree. I hope you understand the law of cosines and law of sines. You need to make sure, even if you are using calculator, you need to make sure you enter the numbers correctly and enter the trigonometric ratios. The angle, you put that in parentheses, and the quantities always, if you want them to stay together, use parentheses.